Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nusha Zuina Akidah binti Abdul Hamdan with number matrix 1212873. Now I will be presenting on the Excel assignment for financial mathematics. Question 1. Alia plans to take out a loan of 350,000 ringgit at an effective rate of interest of 4% per annum for the first 3 years and at an effective rate of interest of 5.5% per annum thereafter. For Alia's loan structure, it is stated that no loan repayments were made for the first 18 months. After that, level loan repayments are made every month and the loan is to be fully repaid in 25 years since that loan is taken out. For this such case, if repayments are insufficient to cover the interest due every month, then the outstanding loan balance will be increased to cover the shortfall of the loan. Construct the monthly loan schedule. For the first question, I constructed a table containing the amount of loan, period, rate, and payment. For the amount of loan, as stated in the question, is 350,000 ringgit. And for the period, stated that 25 years repayment. So I divided it into 2, which is 3 years times by 12, which is repayment paid by monthly. And the remaining 22 years times by 12. So 36 and 264. Also, same goes for the rate. I divided 4% with 12 because it is stated monthly. And 5.5% also divided by 12. For the monthly loan schedule, it is stated that no loan repayments were made for the first 18 months. So the payment for the first until the 18 month is 0 ringgit, but we only calculated the interest for the period, during the period, which is 1 to 18 months. So the interest is calculated by the outstanding loan balance times by the effective rate, which is 4% divided by 12, because it is stated that the first 3 years we use the 4% effective rate. So the interest for the first until 18 months can be calculated by that way. For the principal, we can calculate it based on the formula, the payment, subtract the interest. So we will get the negative sign for all the principals from first until the 18 months because since the payment is 0 ringgit, right? So for the outstanding loan balance, we just can calculate it by the outstanding loan balance for the first time, for the beginning, minus the principal. So since the principal for first until 18 months is negative, so the outstanding loan balance for the first 18 months will be increasing until the 18 months. For the next 19 up to 36 month, we use the rate for 4% divided by 12 because the first 3 years rate is 4%. And since from the 19th month, there is payment that can be calculated. So we can calculate the payment by using the formula C3, which is the rate, and the remaining period after we less the 18 month earlier, which is 282, and negative B25. B25 is the outstanding loan balance for the 18 month. We use negative signs so that our answer will be positive. And then since the payment are constant through from the 19 through 36 month, so we get that our payment is 2,034 ringgit and 77 cent. Next, for the interest, we can calculate our interest by using the formula B25, which is in this case is the beginning, which is the period outstanding loan balance, multiply by C3. C3 here is 4% divided by 12 because we use the rate for the first 3 years. So we can get the interest for every month up until 36. For the principal from 19 up until 36 month, we just use the same formula, which is payment minus interest. So the constant payment minus interest that we get for every month. So we can calculate the principal until the 36 month. Next, for the outstanding balance, which is outstanding loan balance, we can only calculate it by the outstanding loan balance for the previous period minus the principal that we get for each month. To calculate the interest, since we need to multiply the rate by the previous outstanding loan balance, so we can log the cell of the rate, which is this C3, by adding the dollar sign at the in front of C and 3. And the only changing item is the previous outstanding loan balance, which is this B column, as we can see here. Starting at the 37th month up until at the end of the loan repayment, we just use the same formula, but we need to change the interest calculation for the 5.5 divided by 12 rate, because it is effective rate that we use at the remaining years after 3 years. And we can get the outstanding loan balance at the end of the period is 0 ringgit. For the interest calculation, it is the same as the calculation before. So we need to log the cell of this rate, which is D3, by putting in the dollar sign in front of the D and 3 symbol. And we can calculate the interest of the 37 up until 300, because 25 years multiplied by 12 is 300. So we can calculate the interest for each month up until at the end of the loan repayment. Also, same goes for the outstanding loan balance calculation. We only need to subtract the previous outstanding loan balance and the principal that have been calculated for each of the period, for each of the month. And at the end of the period, we should get the outstanding loan balance is equal to 0. For the question 2, given in the Excel sheet are the effective yield of 20 different banks, which is bank A to bank T. The annual yield rate are for investments of different terms from 1 to 10 years. First question, identify which bank offers the highest 1-year forward rate at time 5 years. For the first question, I just copy and pasted the spot rate for each bank up until 5 years only, because we need to find the 1-year forward rate at time 5 years. So the 1-year forward rate at time 5 years is at the year 4. So our symbol is going to be F in the bracket for 5. So the formula is 1 plus the spot rate of the 5th year, which is this, to the power of F2. F2 here is the 5th year itself, and divided by 1 plus the spot rate of the 4th year to the power of 4, E2. And we can log these two cells, which is F2 and E2, to maintain the same answer up until the last bank. And by referring to the formulation that we have learned as well, we need to subtract this formula by 1 to get our forward rate at time 5 years. So our formulation is going to be pasted up until the last bank. So the bank that have the highest 1-year forward rate at time 5 years is Bank L with 0.998%. Second question, identify which bank offers the highest 2-year forward investment rates starting at time 7 years. For the second question, since it has mentioned that 2-year forward investment rates starting at time 7 years, which means starting at time 7 years, forwarded 2 years is 9 years. So the formula is going to be the same as the previous question, but we need to change the year and the spot rate depending on the years. For the calculation is 1 plus J27. J27 here is the spot rate at 9 years to the power of 9, which is the power of the year, divided by 1 plus hash 27, which is the spot rate at the 7 years to the power of hash 26, which is the year of 7. And this needed to be powered by 1 over 2 minus 1. Next, we can copy and paste the formula. But before that, we need to log the cell of the 9 and the 7 year, which is J26 and hash 26. So we can calculate the highest 2-year forward rate investment starting at time 7 years? And the answer is bank K with the forward rate equals to 2.841%. Next question. Later, Aisha would like to purchase a 10-year increasing annuity certain from one of the banks listed above. The first annuity payment made by Aisha is 2,000 ringgit and the subsequent payments increase by 500 ringgit every year. Third question. Identify which bank provides annuity at the lowest cost. For the third question, since it is mentioned that Aisha made her payment from 2,000 ringgit and the payment subsequently increased by 500 ringgit every year, so we can list down the payment from year 1 up until year 10, so we can get 2,000, 2,500, and up until year 10 is 6,500. To identify which bank provides annuity at the lowest cost, we need to calculate the present value PV for each bank. For the calculation, the formula for PV that we need to use is RV1 plus RV2 plus RV3 and up until RV10 because there is 10 years. Next, for R is the payment that we have listed down, which is 2,000 until 6,500. So, cell for each R will be locked by putting the dollar sign in front of it. Multiplied by V, which is, as we know, V is 1 plus I to the power of negative N. So, I we use is the spot rate for each bank for each year. To the power of negative N. For example, if we calculate the first year, we need to power the 1 plus I by negative 1. And same goes to the year thereafter. The formula is going to be the same, which is RVN from the first year up until the 10 years using the previous formulation that we have done. The important part is we need to lock the cell for the payment, so it will be constant to calculate the PV up until the last banks. After we locking all the payment cell, which is all the R cell, we can calculate the PV for each banks to identify which bank provides annuity at the lowest cost. So the bank that provides annuity at the lowest cost is Bank K with the PV is 37,711 and 64 cents. Last question. Calculate the effective annual rate of return achieved by Aisha on purchasing the annuity from the bank determined in the third answer above. For the last questions, since it is referring to the previous answer, we get that the bank K providing the lowest annuity cost. Since the formula to calculate the IRR is AV over PV to the power of 1 over N minus 1, so we need to calculate the AV for bank K. The formula to calculate the AV is R multiplied by 1 plus I to the power of N minus 1, N minus 2, N minus 3 for each calculated years. So to calculate the AV for bank K, we need the formula of R multiplied by 1 plus I to the power of 10 minus 1 or 10 minus 2 and 10 minus 3 up until 10 minus 10, which is up until the 10 years. We can use the R as we listed in the previous question, which is 2,000 until 6,500. For example, for the first year, which is 2,000, multiplied by 1 plus B90. B90 here is our spot rate for the first year, to the power of 10 minus B79, which is 10 minus 1. And we can use this formula to calculate our AV for the second year up until the 10th year to calculate the accumulated AV. At the end of the answer, we can get our AV is 45,458.57 cents. Lastly, to calculate our IRR, we use the formula AV over PV to the power of 1 over N minus 1. And in this case, the N is 10. So AV over PV to the power of 1 over 10 minus 1. Our AV is calculated as L90, which is this value, divided by L66, which is the value that we have calculated in the previous question, to the power of 1 over 10 minus 1. And we get the answer for IRR is 0.0189.